Good morning. Thank you for joining. So, what's the agenda today? We'll talk about. I will tell you a lot of stories, and we'll try to see how can people or my 5-year-old son can actually build neural networks and make predictions. I will also show you some hands-on neural network techniques, and then I will give you 10 key terms that all of you need if you're starting in AI, if you are giving AI interviews, or even if you're writing strategy, or you're figuring out what next in AI. These 10 terms will be so widely used that once you know them, you will see them everywhere, right? So that's the agenda today. This is the talk that I was talking about. This is Andrew Karpathy talking about he was just talking about intelligence general, and he used these terms like weight, backpropagation, gradients 137 times. This means every minute he was just throwing a term like that at you. This was a 120 minutes video, and 137 times he used terms like these, which most of us may not understand, or if understand, then don't know what they mean. And then you can't follow these people. If you can't follow these people, you don't know what's coming, or at least build the strategy around things. So that's the idea of today's session. Jeffrey Hinton got a Nobel Prize for the same thing that we're going to learn today. So story of Riddhi that I already told, which is people getting phased out in meetings. They think that AI is not for them because they can't make sense of these technical terms. And in my experience, these terms are very basic and simple to understand, and are not even that important in building strategies. But if you don't know them, you create this FOMO inside you, and that way you lose a lot. So my goal is to make sure you don't lose a lot. So without further ado, let's get started. Neural networks for mortals. Okay then, what are machines? Machines, what is machine learning? Machines have data, and with data you can find patterns, and with patterns finding after finding patterns you can do predictions. That's pretty much the idea of bare bone basics. Okay? But how you find patterns from data? That's where we have spent last 50 years figuring out how can you find patterns in data, and there are techniques for it. But before we go to that techniques, let's just understand, if I want to make predictions, or my son want to make a prediction, if there is a movie running, will I go, or will we go and watch the movie or not? But before my son makes the prediction, let me make a prediction for all of you by writing a simple equation, which is y is equal to x. So all these models, all the machine learning is nothing but an equation or a mathematical equation. This is the simplest equation, which is x is the input and y is your output or your prediction. So this is the simplest equation, that if you live in Seattle, like we used to live in Seattle, if there is any movie that a new movie shows up, we will go to the theater and watch it, because there's nothing happening in Seattle over the weekends because it rains all the time. Anybody from Seattle? Sorry, I'm not selling Seattle well, but hopefully you got it that you need to watch a lot of movies. Simple equation. So if there is a new movie, I will go to the theaters. So input is new movie, and the prediction is yes. If this is one, then this is one. If there is no new movie, then this is zero. I'm 100% right. This is the best machine learning model ever created. 100% accuracy. If there is a movie, I will go watch the movie. But then our son was born, and then we realize that the equation is a little bit different and have more variables in it. It's not that we can go simply just watching movies. So the equation evolved that we have inputs, and we wanted to see like their values, and the inputs were, hey, can we get a babysitter, right? Can we get a babysitter? And do we have tickets? Now we become picky also. Once you have kids, you think your time is value. Before that, you don't value about your time, but your kids, the first time you know that your time is actually valuable, you start waking up early, you get a half hour. It seems like eternity. So you figure out, do you have tickets before or after? Before, have you booked the tickets or not? Can you get a babysitter or not? And is what kind of movie is it, or your other preferences, which is, can I watch the trailers? Can I leave early enough to watch the trailers? These are the values, right? And then you wanted to make a prediction. The equation became, if x1 is true, x2, x3, and that became our equation. And then there was an activation function. Let's put an activation also, which is that, hey, this whole three, so these value can be one, then tickets are there or not. Sometimes it's zero, and I can watch trailers. There is enough time. Then this value is three. I can put in saying, so if it is positive, earlier it was very simple. If it is positive, we are going. If it is not positive, we are not going, like one or zero. But now I wanted it to have some big deal around these numbers. So what I did is I put a function and I call it an activation function, which is, will we activate or not? And if this is, let's say we called it ReLU 2, and the idea was, if some of these numbers is more than 2, then only we will go, because ReLU 2, what it does is, anything less than 2, it converts it into 0. Anything above 2, it says 1. Then our prediction will become, in this case, will we go for the movie or not?
Yes.
Okay, if I change it and I can't watch the trailers,
So
will we go or not?
it's
No.
2, so it's yes.
Yes.
Okay, and if I can't watch the trailers, and if we will be late also, which is 0, and
No.
we'll like miss 10 minutes, which most of you missed if you just joined the course,
No.
just joined the call,
No.
No.
then it will become 0, even if it is possible. So this activation function, what it is doing is, it is figuring out or bringing some non-linearity. Otherwise, it was linear. If it is positive, I will go. Now it's a non-linear function. I can change it to 6, I can change it to 12, and I can now play with what things become, or when can I go and when can I not go. This makes me do better predictions, right? But then he figured out one more thing, which is that all these are not equally created, right? We cared about some things more than the others. That babysitter was pretty more important than watching a trailer,
Weighted average.
right?
Mm.
So these are the values. These are the values on that day. But actually, he figured out that they are not equal. So he assigned weights to them. He said, you know what? They care a lot about babysitter. They don't care a lot about tickets. So let me assign a weight of 2. And they care about trailers, but they're not really picky about it. So let me give a weight of 2 here and maybe 1 here. Good. So now his prediction started getting better, which is, now the new y became not just x, but these are the x values, x1, and this is the weight value. And now the equation becomes x1 plus w1, x2 plus w2 plus xn to wn. Everybody ready for a math class? This is getting into a math class, right? So what is
Very
happening here? All I'm doing is I'm checking the values of what matters to this person, and then I'm assigning different weights to it, right? And now I can incorporate, if babysitter is better, if having a babysitter counts more, then this value becomes 4, this value becomes 0, and this value becomes 4. And then I can put ReLU 6 as a function. Will I go for a movie or not?
Yes.
And if I change the weights of this guy from 2, will I go for the movie or not?
No.
Great. So now you understood the first equation, which is the primary function, and there are only 3 more variables, and you will get everything about neural networks. The idea is that the equation is not, is y is equal to wx, where x can be matrix of different variable, x1, x2, x3, up to xn, and it needs to be multiplied by the weights of how much weightage each input variable should carry if you want to make predictions. Good. So that's W1, W2, W3. Now my son actually grew up and he has friends, right? So my son grows up, he has friends, and even if the same variable, same X1, which is babysitter, trailers, or advanced book tickets, and if he wants to carry other people, like his friends, Brooklyn and Rishabh, their parents needs to come also, right? Because I can't take them to movies, they want to carry, but different family have different biases for action. Their parents don't like movies at all, so they will come up with some excuses all the time. These people love movies like us, so they will even prop us and give us like, hey, it's okay, don't, it's okay to go for trailer. So now I have to add bias because the world is not as static as just weights and weights and my inputs. So what I can do is for each family, I can add another thing to my equation, which is bias of action. Good. So every time I can also say that, hey, y is equal to wx plus b. And for Brooklyn family, I can keep this b as positive. And for Rishabh family, we can mark it as -3. And for these guys, we can mark it +3. And for us, we can mark it +3. And then also, my equation gets better because we will go for movies when these three families will go for movies. These two people can come along. And some people are biased to watch movies, some people are not. So now I can add another equation, another variable to my equation, which is bias, which helps me code who reacts or who doesn't react in the world, or when this thing works and when this thing, the randomness of different families of different attributions. So that makes my equation become even more sophisticated. And now I can put lot of, I have a way to store beyond weights and bias, weights, the bias of the world into my equation. Good. So now I
So,
have my equation becomes y is equal to wx plus b. Good. B is the
it,
matrix of all the biases I can add to all the families that we want to carry or different attributes. That day, if something strange happens, that is the bias. We can make it positive, negative. We can calculate the weights of how much we carry about these things. Same story. Okay, if you got this much, you got most of it already. So just to calculate these numbers, can I write them in a fancy way? Can I say that, hey, these are your x1, x2, x3, and this is your y, and your w1, w2, w3 are here, and your b1, your bias is here. Like one attribute, one bias in the end. Same page? This is the same equation, right? X into W1 plus by B in the end, X1, X2. And then you have this equation called Wx comes from this multiplication and this bias is added in the end. Good. And I can make predictions. Same equation. Everybody following me? Good. Estefania is like now he's getting really serious because he drew this thing here. Okay, simple, right? We were doing it in the table. We put x1, we put w1, and in the end we added a bias. So our x1 was babysitter not, our ticket was not, babysitter, tickets, and trailers. And then we put weights like 4, 2, 3. Similarly, this is like 1, 1, 0, 1, 2, and your weights are 4, 2, 3, and multiplication by adding something called b outside is the value of y. Correct? Okay, if you got this much, you got neural networks mostly, then what happens is maybe the world is a little more complex, that it doesn't always give always the straightforward results. So let me add some more layers to this, and I move my Y here. So I have some weights and some intermediary stage, and these are just new variables that I introduced into this equation.
Mahesh, can I ask you a question before you go there?
Can you wait a little bit? Let me just
Sure.
move on, and then I will stop for questions. Just let me
Okay.
drop this, and then I will
Sure.
take few questions. Okay, you got xn. So now I added few more parameters, few more intermediary stage. Let's call them hidden layers. Some hidden attributes. So in W1, W2, W3, same story. And then I can keep going more. And these are new layers or new parameters I added so that I can do better calculations, because there are some things as not as simple. I understand the weights for this one, but there is more in the world. So I can keep adding more complexity to this by adding more and more neurons or more and more layers. And this becomes your neural network. This is nothing but neural network. It consists of nothing but your inputs, which is your x1, x2, x3. You pass the inputs. Then you can have your weights and you can have your biases on each layer. And in the end, you get an output, which is 0 or 1. Good. Y is equal to wx plus b, and I can make predictions. The assumption here is that you know the weights and biases. What's the perfect number of weights and biases? Because 4, 2, 3, I knew them. Because Kabir knows, Kabir is my son name, by the way. Kabir knows our family, and he has these numbers that are accurate. Good. Okay, two questions, and then I move forward and I show you the magic. If these numbers are not accurate, what happens then? Because nobody knows. If I want to make prediction for Estefania or Harleen or Salim, then I don't know these numbers. Kabir only knows these numbers for our family. But if I want to make predictions for their family, I don't know they care about babysitter or not. Maybe they don't even have a babysitter problem. What's their problems? What are that weights and biases? What are their problems? So I put some hidden layers that I will learn. I don't know the problems that you or your life has. So I put some variables more to learn your lives, but I don't know their weights and biases also. Right? For our family, we know. For Brooklyn, for these people, we know from our experiences. But if I want to make predictions for all of you, my only problem is I know Y, I know X, I know what why I want, which is whether you will go for this movie or not, given a new movie, but I don't know what the weights and biases to set up. That's the open problem right now, and I will solve it after two questions. Sonia, Roma, and somebody who said in between that they want to ask a question.
Hey Mahesh, so if we adjust the weights per family, wouldn't that suffice, or is bias generalizing the equation for everyone?
Yeah, so the weights for per family is there. That's the one variable. But then there is this random thing that they are not in mood. They just have this, like, even if they don't follow this standard form, that even if the weights are saying that let's go, they will have some random excuse, which is like, hey, sorry, I have a headache today. And their dad always comes up with this idea. So beyond weights, also there is randomness in the world, and that randomness is encoded as bias in these equations. Roma.
Thank you, Mesh. The questions in the chat as well. Are you able to give us another example for bias so we can understand it better? It's still a little murky, at least for me, and I think a few others in the chat. Thank you.
Yeah, so the idea of bias is that, hey, how can you add or how can you? So these equations are basically trying to understand or model the real world. A real world will have inputs, then weightage to those inputs, and then there is some randomness of this idea that, hey, how can I do sometimes this thing out of blues? Because sometimes you go and take a class, even if it's your work hours, and sometimes you will never ever take a class if it is your work hours. That is not weightage. That's just your bias that day, or bias for action, or bias to go and do certain things more than certain things less. So that has, like, if I can encode that in a mathematical equation and learn that also more than your weights, people figured out that they were able to make better predictions. So they needed a storage number, which is like, okay, this is how much you care about this thing. But then there is this random piece of when you care and what you care. And that was, they wanted to learn. So they added another variable, which is, even if all this is true, let me add one more thing to learn, that what happens in these circumstances, or is there a certain pattern there also? And now I'm learning it in biases. Good. All of us are same page. But now I don't know your weights and biases. So what can I do? If I need to predict for Meher, Roma, or Estefania that whether they will go for a movie given the same movie, I need to make the predictions for them, because our family, he makes prediction. He's not going to make money. He's going to have fun. But to make money, he need to predict whether all of you will watch that movie or not. And if he can make that predictions, that's what, by the way, we did in 2018. One of my friend and we started like putting these networks together and figure out which movies will work, and then we can buy the rights of that movie to run in America. We were buying Indian movies only, so we use these networks to figure out which movies we'll buy, and then we can buy the rights to run those movies. Uh, so if I needed to do that, I needed to understand the world, and the weights and biases need to be generic, that I can figure out how this culture or this thing works. Good. Okay. Then what can I do? My network is quite solid. I have figured out working in my house that we need this network with y is equal to wx plus b. And I created this awesome network also. So now I can put some random values in weights and biases, right? This x is constant. Let's say that's what the movie characters are, who the actor, actress, who the director, what genre, what year, all that is your x1, x2, x3, all the variable about that movie, which is known to everybody. And the more better these weights, I just set them to some random values, right?
So, Mahesh, it's gonna be like if the actor is Shah Rukh Khan,
Yeah.
it'll have more weight to it, basically.
Yeah, no, weights are random, but Shah Rukh Khan will have a number in x1.
Okay.
The name is SRK will have its own number, which is 0.7. Kajol is 0.9, and Karan Johar is 0.11. Right? That's your input, X1 about the movie. And let's say genre is love story, which is 0.25. And you can keep going on and on. The more variables you enter, the better it is for me to predict. But these numbers are random numbers. They have nothing to do. You don't know the weights. You
Okay.
don't know, I don't know your weights about them. I need to calculate them. So the best I can do is I can put some random numbers here. I don't know the weights. I put some random numbers in the bias also. Let's put 7, let's put 3 just for fun.
Hmm.
Good, some random numbers. And then what I do is I input this movie into this equation, the whole value of x1, x2, x3, and I make a prediction. Who cares? I say Priya will not watch this movie. Okay. So there is a movie running, and we will say Priya will not watch that movie.
Hmm.
But Priya says that, sorry, Mahesh, we watched the movie. You're wrong, Mahesh, because you put some random number. What do you think? Will you guess my life? Will you buy this? You will become rich by just putting some number and making this graphical diagram. You're going to learn this, and then you will be rich. If this is how you can be rich, then everybody will be rich, Mahesh. So now I have a problem that actually somehow automatically, without talking to the Priya, Dan, or Dannies of the world, I need to go and learn how these numbers needs to be changing, or how to change these numbers. Good. So if I need to change these numbers, I need to put learning in these machines. This equation is good, but how can I learn once you tell me? So this is the idea of labeled data, that at least to learn, I need to know is Priya, I need to get a list of movies, movie 1, movie 2, movie 3, and then Priya's data, which is which movies Priya's watched, which movie Priya didn't watch.
Hmm.
Good. If I have this data, at least I know when I'm wrong. And let's say this is random. So let's say I'm right 50% anyways. Right? So if I'm 50% right, then what can I say? I can say that, hey, this model is accurate 50% of the time. Good. If I made the same predictions, then I'm right 50% of the time. All I did is I put some numbers, I randomized them, but I'm 50%. But who buys a 50% number? It's flip of a coin. You can just say that, yeah, they will watch the movie. That's what our neural network is doing right now. And with that, we can't make any business or money. So let me calculate a cost function of how I come to 50%. So if I said 0, 1, so there is another function, let's say cost function, whose idea is that, hey, what's the cost of this? If it is 1, 0, which is I predicted 0 and you said 1, then the cost is quite expensive, which is 1. And my job is to minimize this cost. If I can bring it to 0, which is when I say 1, you say 1, when I say 0, you say 0, that means if it is 0, this will be 100%. Our accuracy will be 100%. I can make all the prediction. Make sense? So I have this function called cost function, in which what you do is the model predicts something like 1 in this case, and you subtract from what was the actual, which is minus 0, and that's the value of the cost function. And your job is, as a machine learning engineer or an engineer or this person who wants to make money, is to minimize this cost function. Good? Same page? So now I have an equation and now I have a function. So this is ReLU 6. This was my activation function. And now on top of it, I also created this new idea of a cost function. Same page? So this, if I can take this equation and reduce the cost of it, I will be golden. And I can figure out how to reduce the cost of it. Same page? So my life becomes, how can I reduce this cost or make these predictions correct every time I make the prediction? Good. For that, once I know this value has to be 1, that actually Priya watched the movie, even if I'm saying it's 0, actual value is 1. Can I go back and change the weights and biases manually? Can I make some changes here and there? Because these are my numbers, right? I can't change X because the movie actor, actress, genre can't change, but I can go and change the values of W and B. Same page? And if I can change them to become 1, then my model is good. My cost function is getting better. But I want to find the minimum changes that I can make to this equation mathematically and not manually or automatically. That's where the learning or the neural networks became very popular. The idea is this function, you're trying to find the minimum of this function, right? Minimum is basically the lowest value, because highest is when I pay the maximum taxes. I make a lot of predictions. If it is 0, I'm happy. And the idea of this gradient, which is a mathematical term, which helps you find what is the value of a function in future state. If you take this dx and divided by dy, which is a mathematical term of derivatives, forget the math. The whole idea is that how can I find, if it is an x and y plane, the minimum value of this function, right? I am here, which is 1, and I want to go reduce this function to find the minimum value of this function, right? So if I can go and keep moving in this direction, which is telling me a negative gradient, so I can calculate this gradient, and gradient tells you whether you want to go in direction up or down to reduce the value of this function. This equation, when it will be producing the less number, is the direction. And the steps, the length of steps you take to move towards this is called learning rate. Like the speed of learning. You can learn faster, right? You can take bigger steps, or you can take much smaller steps. That's your learning rate. And finding the value of this gradient where it's minimum is called gradient descent. right? My job is what? To make sure that the cost function where Priya, the predictions we are making for Priya is minimum, and there is a mathematical function gradient which tells for any equation in which direction can I go to reduce or find the minimum of that function, right? That formula or that math is called gradient, which helps me minimize this function value by taking steps, and the length of the steps is called learning rate. I know it will get a little complex here, but just follow for 5 more minutes and I think you will get everything. So the idea is that I need to reduce the value of this equation or the cost function. And for that, there is a mathematical terms called gradient. If I take the gradient of this function, I want to minimize it and I want to find a minimum value of this. And that I can do by figuring out or calculating the gradient. Gradient tells me in which direction should I move. I move here, it gets lower. If I go up, it goes higher. So I will take the negative gradient of this cost function. This is it. This is all the math and everything. So this is the gradient negative because you are calculating the minimum. This is your cost function for neural networks, which is Wx plus B plus an activation function, which makes it non-linear. You calculate the cost because you want to minimize the loss. And this one, what it gives you is, if you calculate this, what it gives you is, you got those weights and biases, remember? Right? I have those weights and biases, the numbers randomly. Once I calculate this function's gradient or negative gradient, it gives me for Priya the best numbers, the weights I need to go back and change in this neural network, right? In this this is a weight W3, this is W1, W2. If I list them all here, which is 0.3, 0.7, 0.9, this was my random weights. And if I calculate the minima or this gradient, negative gradient, it tells me the values I need to go back and change that, hey, reduce this by 0.1, increase this by 0.2, and increase this by 1.1, right? It gives me the values which I need to go back and change. So this is my W dash, this is my W1, and now I can go back and change the value. So if this was 0.3, I make it 0.1. If this was 0.7, I make it 0.2. If this was 0.9, I make it 1.1. And now my cost function becomes minimum, which is 0. And I say Priya will not watch the movie if I change the weights. And that came from this technique of gradient descent. Now I have an equation and I can take a lot of these data for Priya, for Harleen, for Robert, for Rodrigo, and I can run this and keep adjusting these weights and biases. So all of your data, all the movies you watched, I'm highly accurate on all of them because I adjusted the weights and biases backward. Good. Then I can make all the predictions correct for all of you. And hopefully in this going backward and forward, so this forward is forward propagation and backward propagation is this idea of adjusting the weight. In forward, I'm just making the prediction. I'm just multiplying the W's with X that people give me and adding the B's and giving an output. And then I go back and adjust the weights and biases so my results are always accurate. Good. And once I have trained this weights and biases, then I can launch this model. I can make the predictions for random new movies also that I have never seen. And if I have learned these variants and biases or build these new things in a more generic way, or I generalize the learning or the patterns that how people perceive movies, actor, actress, genre relationships, then I can go and start making movie predictions. And if I can do that, I can buy the movie at a smaller price, knowing that it will be a hit. And if it becomes a hit, I can make a lot of money. That's exactly what neural networks or these networks do. They help you predict, they help you see. And now, if you have learned this much, My last learning today for all of you is the terms. So there are 10 terms here, which is what is model. The model is nothing. You go through this term backward, forward, and the final value of this matrix W and by B, when you say that, hey, we trained these, then you say, I am doing a model checkpoint. A model checkpoint is nothing. The final value of W matrix, B matrix, that's your model. When people say this is a machine learning model, we are releasing GPT-5 and we are open sourcing the weights. They are basically telling you what the final values of weights and biases are. An open source model is where you can see these weights and biases. Can somebody give me an example of an open model?
DeepSeek.
DeepSeek, Llama, GLM5. All these are where you can see these weights and biases. Closed source labs, they train these models. They say, you give me the input, I will give you the output. I won't show the magic. And I will not tell you how I trained these, like the techniques I used. While open source model says that, hey, I will tell you how I trained it, what data I used, and I will also give you the weights and biases so you can store them wherever you want and you will get the same prediction which I am getting. So that's the difference between model, open source and closed source. Okay, people, second term is parameters. So what do we people mean when we say parameters? You heard this term like, large models, big parameters, 175 billion parameters, 1 trillion
XY.
parameters. Anthropic just said that they are training the model with 10 trillion parameters. Then means more parameters means a better model. But what is a parameter? X.
Your axis.
In this equation, weights and biases are basically parameters, right? So that means they have put random 10 trillion weights and biases and train those 10 trillion weights for all the data in the world to find the patterns of a next word prediction, right? So now you understand model. Now you understand what are parameters. So next, what is inference? When people say, hey, we are using this inference API, what is inference? The idea of inference is very simple, that once you have the model, which is nothing but trained parameters, if you give it an input X, it detects Y and it doesn't go backward, it's a fixed value. This process is called inference. If this is called inference, then what is training? Training is a process where you go and you open this up. You don't make them fix. You go forward and you also go backward and you change the value of W and bias and you do this forward backward process. That's the training process. So when they say we are training a model, they are saying they are changing the weights and biases going forward and backward a lot of time till they reach the final value of weight and biases, right? And that will be your model for inference. Okay. So now you understood back propagation, the process of going back and changing the weights and biases to make sure that the movie productions are correct is called back propagation. What is gradient? Gradient is a function which allows you to say how much should I change the weights and biases when I go back. That's your gradient or your gradient descent, or more sophisticated way, stochastic gradient descent, SGD. If somebody throws that term at you, don't run away from that meeting. Stay there, hold your ground and say, ha ha ha, nothing. He's just figuring out what weights and biases to change so that they can make the right prediction once they know what the prediction is. That's pretty much it, right? So this is an optimizer function called stochastic gradient descent. There is another one called Adam, and you can use any of those. So these are called optimizer functions because they optimize what weights and biases needs to be changed, how much they needs to be changed, so that we can keep the learning or keep generalizing the learning rather than just learn for Harleen, but then forget for Salim, learn for Salim, but forget for Gina. How can we generalize it? That's the function of optimizers, like changing these weights and biases. Okay, training we got, Then we have this idea of layers. The idea of layers is adding more weights and biases by adding more neurons in between. I just used 2 hidden layers. You can have 200. Last I checked, the attention layers had like 8 hidden layers, and then they had 64 in that. One layer had 64 neurons. So those are layers. Weights, biases, neuron activation, hidden layers, training, optimizer, gradient, back propagation, inference. Now all of you are researchers. That's pretty much all they talk about. Thank you very much. This was an awesome. I know it took you a lot to follow along. I know some of these things may not be all clear, but hopefully I get you started on this journey, and hopefully this is doesn't feel like too much work. So I gave you the equation. I teach this course where I try to simplify machine learning and AI for all of you. If you want to join, you can join today. And we put you on a 10 to 12 weeks of 2 courses, and you can get both of them with Saturday, May coupon code, which reduces your price from 6,000 to 3,200 for 2 courses. And you will come with me for a 10 weeks ride where first we will make your fundamentals strong, then we'll teach you what it takes to become an AI product manager, like how to find, identify opportunities in AI, how to put roadmaps, how to evaluate, how to price, and how to put GTM motions. And also I will talk about these concepts. I put these fundamental concepts outside the course in this free class because I want to focus on chain of thought, knowledge, tools, MCP servers in the class, in the concepts. I think those concepts are important if you're building agents or getting into agentic AI. And then you will also build a project or a full-fledged app that can go to production. Okay, that's the course. Okay, with that, hopefully this was helpful. Hopefully this was useful. And hopefully, if you're joining our cohort, this will help you understand intelligence to a much deeper level than just knowing there is intelligence and these are black boxes and they can just predict anything. Maybe you can talk a little bit more thing. And maybe when you read these things, when you listen to these podcasts, now you will get a lot out of them rather than getting less out of them. See you. Bye.